We can summarize our examples. We live in the object-oriented world. The object-oriented programming paradigm attempts to express computer programs in such ways that model how we understand the world. An introductory description of object-oriented programming can be based on the following guideline. The solution to the problem should resemble the problem, and observers of the solution should be able to recognize the problem without necessarily knowing about it in advance. A good example of this guideline from the computing world is the use of object-oriented programming to develop a stack class from which stack objects can be instantiated. If a stack is implemented as a class, instantiated as an object, and documented appropriately, programmers familiar with stacks, queues, and other similar data structures will recognize it as a stack without other prior knowledge. 2.4 A word of object-oriented programming vocabulary. The style of programming in pre-object-oriented programming languages and object-oriented programming languages once are different as well as their vocabularies. Here you are an example. There is no procedure anymore. There are class methods. Yet another example. An object-oriented programmer may define an abstract data type by encapsulating its implementation as interface into a class, while more instances of the class can then be instantiated. An instance of a class is known as an object. Every object has state and behavior. State is determined by the current values that are stored in the instance variables. Behavior is determined by the instance methods of the class from which the object was instantiated. Inherited abstract data types are derived classes or subclasses of base classes or superclasses. We extend superclasses to create subclasses. Within the programmer instantiates objects and sends messages to the objects by invoking the classes, methods, or member functions. Instantiate an object means create an instance of a class. An object-oriented program defines abstract data types, encapsulates those abstract data types into classes, and instantiates objects and sends messages to the objects. To make these words even more confusing, almost every time or action used in the object-oriented programming vocabulary has evolved to describe by several different terms. Often depending on the authors who wrote the particular book you are happy to be reading. For instance, we can cause an object to change its state by sending it a message, invoking its methods, or calling its member functions. 3. The characteristics of object-oriented programming. Having explained the main ideas of an object-oriented program, let's have a look at the question in detail. What is an object? Let's consider the three general questions. What are the objects in object-oriented programming? What should be the objects in the design of an object-oriented program? What is it about object-oriented programming that sets it apart from and possibly makes it better than traditional procedural programming? Simply stated and taken with a very liberal view, an object is an instance of a data type. The following Java code fragment declares two objects. The first object is an instance of a simple integer variable named time. Some computer scientists would not agree that this is an object. They think an object should not be intrinsic to the language itself. This may be correct in general, but we are talking very liberally. The second object is an instance of an abstract data type. An object is named man, and an abstract data type is named person. Int type, an instance of an int type. Person man, an instance of an abstract data type, identified as person. As you know, summarize, the integer data type comes from the types which are intrinsic in the language and named primitive subtypes. Let's suppose the abstract data type named person you have invented and declared somewhere. From the language point of view, this is a new data type. 3.2 Abstraction. Abstraction is the specification of an abstract data type.